Hello, and thank you for studying CCNA with Vambar. Today, we will start our discussions of how routers do what they're supposed to do, meaning routing. For that reason, first we'll do a quick review of how routers learn different paths to different networks. After that, we will introduce ourselves to static routes, and we'll learn how to configure them on a Cisco routers. Then, just as any computer needs a default gateway to reach a destination beyond their scope, routers too need their default route. And in the end, we'll verify static routes that we have configured. In some of our previous lectures, we discussed in great deal how exactly routers route packets to the correct destinations. We also said that in order for a router to route packets to a specific destination, it needs to know the exact path to that destination. However, routers by their nature have one limitation. Routers cannot see past their directly connected networks or neighbors or routers. And because of that limitation, routers by default will never learn about any networks that lie behind those routers. So, for example, router A will never know what lies behind router B. And router B on his end will never learn what lies behind router A, router C, or router D. But we said that in order for routers to do their job, they need to know the exact path to those networks. So somehow they need to learn about those networks. Well, there are two ways to do that. First, you as an administrator tell the routers where a specific network is and how to get there. And this is called static routing. For example, if router A needs to reach the network 20.20.20.0 that is connected on router F, well, we need to go to router A and tell him manually that it needs to send the packets for that network to router B. Then go to router B and tell it to send those packets for that same network 20.20.20.20 to router D. And then go to router D and tell it to forward the packets to router F. On router F, we don't need to configure anything since router F is directly connected to that network. Of course, you could choose any other path since you're the network administrator and you know the topology you're dealing with, as well as the link speeds between all the devices, so you can make the best decision. Now, since we've configured that, if we have a host A with an IP address of 10.10.10.10 that needs to send the packets to host B who has an IP address of 20.20.20.20, and the packet arrives at router A, the router A will check his routing table and it will determine that in order to reach the 20.20.20 network, it needs to send the packets to router B, right? That's what we said on the static routes. So then he will simply forward those packets to router B. Router B, in his turn, will check his routing table and see that in order to reach that same network, he needs to send the packets to router D, which will send it to router F, and then everything will be great. So as you can see, static routes can do their job, but they have a couple of limitations. The biggest one is their convergence issue. If the link between router B and router D is to fail, then all the packets for that network would have been dropped, even though we can see from the topology that there is an alternative. So however there is a topology change, we have to go and manually adjust the routings, meaning manually adjust the static routes. The second limitation of static routes is that the static routes are said to be unidirectional, meaning that they work only at one direction at a time. For example, our static routes that we've configured will carry packets to the 20.20.20 network, but if packets from the 20 needs to go to the 10 network, the packets will be lost because simply router F does not know where the 10.10.10 network is. So if you want to make your topology to work with static routes, you're going to have to configure routers or static routes for the opposite direction. But despite all those features, static routes are still widely used today in the networking world because of their simplicity, easy configuration, and no resource demand whatsoever. The second way of telling the routers about distant networks is through the using of dynamic routing protocols. Dynamic routing protocols work in a reverse direction of static routes, meaning that if we configure dynamic routing protocols such as RIP, EIGRP, OSPF, and so forth on all the routers in our topology, then those routers start talking to each other. For example, since router F is directly connected to the network 2020-2020, it will go and tell his neighbors, meaning his directly connected routers, that he knows how to reach this network. Then, for example, router B says, oh great, if you know how to reach this network, that means I know how to reach this network as well, since I know how to reach you, right? So he goes and tells his neighbors also that he knows now how to reach this network. Then router B looks at that update saying, oh, router D knows how to reach it. That means I know how to reach it as well because I know how to reach him. And he goes and tells his neighbors and so forth and so forth. Everybody tells everybody, about different paths of how to reach this network. Then based on all of those updates or all those different paths, routing protocols choose the best path to a given destination and then use it to send the packets to that destination. So if host A is to send the packets to host B, there will be no problem. Also, dynamic routing protocols actually fix the issue that we had with networks failing or links failing. So if the link between router B and D fails, well, no problem. Routers will just exchange router updates saying that this path is no longer available, and another path will be chosen without you need to not configure absolutely anything, right? You can just stay there and see that there was a network change, but the routers chose a different path. However, there is one small drawback of routing protocols is that routing protocols are said to be more resource demanding than actually static routes, and also routing protocols takes more time and effort to get configured properly and to be working properly than actually static routes. But other than that, routing protocols is the way to go when you have more complex and a bigger topology and you want to protect yourself against some link failing. But we will leave the details of dynamic routing protocols for our later lectures, and now we'll focus on the regular, small, easy to configure static routes. To configure a static route, all you have to do is go into global configuration mode and type IP route, destination network, destination subnet mask, and then a next hop IP address. And this is done into global configuration mode. In basic human format, this just says, well, if I want to reach this network, whatever network is, with this subnet mask, I just need to send all my packets to the router or to my neighbor with this IP address. But in case we don't know the next hop's IP address, or in other words, the neighboring router's IP address, we can configure the static route to use our router's outbound interface, meaning the interface route which all packets will reach the certain destination. So the static route command would look something like this. IP route, destination network, destination subnet mask, and instead of the next hop IP address like in the previous command, we put the outbound interface like 00/0/0 or F0/0/0. And this will make our static route, the one that we actually needed. Now that we've learned the commands to configure static routes, let's do one example. In this diagram, we have three routers, router A, router B, and router C. Each of those routers have a local area network that is unreachable by the other routers unless we put some static routes. And first, we'll configure the static routes for router A to reach the networks 192.168.2.0 and 3.0. To configure a static route for the network 2.0, we will use router B's IP address on the serial interface, or the interface that is connected to router A, which is 12.12.12.2, as the next hop IP address again. So we should do the following. In global configuration mode, because that's where we type all the config commands, we type IP route 192.168.2.0 as a destination network, 255.255.255.0 as a destination's subnet mask, and 12.12.12.2 as the next host IP address, and then we hit enter. This will basically tell router A to send to 12.12.12.2 or router B the packets that are destined for the network 192.168.2.0. We do the similar for the network 192.168.3.0, but this time let's use the interface 0/0/0/1 on router A as the outbound interface, because we don't know router C's IP address, even though we actually know it. To configure a static route for the network, we should type in global configuration mode IP route 192.168.3.0, 255.255.255.0 as the destination network and destination subnet mask, and then we type 0/0/0/1 as the outbound interface. This command enables router A to do exactly the same thing as the previous static route command. It just tells the router to send throughout interface 0/0/0/1 all the packets that are destined for the network 3.0. And since this interface is connected to some other device, let's just hope that this device actually knows how to get it, because router A surely doesn't know. It just sends the packet to the direction that which it hopes the network 192.168.3.0 lies. And then let's continue with router B's configuration of its own static routes. To configure a static route on router B, we'll basically use the same picture. All you have to do is figure out that in order to reach the network 192.168.1.0, the router B needs to send the packets out of interface 000, let's say. And in order to do this, all you have to do is in global configuration mode, type the command IP route, the destination network, which is 192.168.1.0, destination subnet mask, and then outbound interface. And in this way, we're just specifying a static route pointing in that direction. We want to configure the static route for the 3.0 network using the next hop IP address 23.23.23.3. All you have to do is in global configuration mode, type IP route 192.168.3.0, 255.255.255, and then the next hop IP address, which is 23.23.23.3. But we also said that routers have one limitation, right? Routers need to know the specific path to a given network in order to route the packets to it, right? In order to send the packet. If they don't have a path to that network, routers will simply drop their packet because they don't want to waste processing power and bandwidth, to give it to somebody else. So in our example here, if we have, our internal network and we have all the different sites in the internet, right? Yahoo.com, some site in China, Cisco, and the government website in UK, all possible in different locations in the world. If we have our host reach them, if he wants to reach the yahoo.com, when the packet comes to router A has to take a look at his routing table and figure out that he needs to send the packets to the ISP, and then the ISP needs to send it to the correct destination. If you want to reach the Chinese website, then the router has to take a look at the routing table in order to send the packets to the correct destination. But inside of that routing table, we need to have, for that specific network, we need to have a static entry. Same thing goes for the cisco.com and for the uk.com website. So you can see that, just for those 4 entries, our routing table starts growing rapidly and rapidly and rapidly. But we humans want to go everywhere, meaning we want to be able to visit every single website in the world. And as you can see, this becomes to be impossible because our routing table has to have infinite, many different paths or different destinations and entries for those different destinations in order to be able to reach them, which is totally, not realistic. So if we don't have a path to a given network, the router will just simply drop the packet. So a solution to this problem is something called a default route. A default route basically says that if I do not have a specific route to a given network, send the packets to either some neighbor or send the packets throughout a given interface. And just by those words, you can figure out that a static route is the best way to configure a default route. So a default route will look something like this. A destination will have 0000 and then it will have the next hop IP address. So if the host A is trying to send a packet to a destination that router A does not have the specific path to it, router A will just simply take a look at the default route and just send it to the next hop IP address with the hopes that he knows how to reach that destination. And most of the times, the default route is router on your service provider, right? Because your service provider connects you to the internet, so supposedly he knows how to reach those networks. And even if he doesn't know how to reach those networks, then he'll send it to somebody else who might actually know how to reach those networks. And in this way, you basically gonna go to the network eventually, because you'll find eventually somebody who knows how to get to that network. So let's see how we can configure a default route. Configuring default route, as I said, is almost exactly the same as a static route. All you have to do though is that to change the destination network and the destination subnet mask with 0000 and a subnet mask 0000. You can also specify the next hop IP address and administrative distance if you want to. Also, of course, you can use the outbound interface instead of the next hop IP address to specify your default route. And then, of course, the default, destination network and the destination subnet mask have to be all zeros. So let's see here an example. If you want to configure default route on router A pointing to the ISP who has an IP address of 67.23.25.9, all we have to do is go into global configuration mode and type IP route 0000 for destination network, 0000 for subnet mask, and then the next hop IP address. So if host A is to send a packet to a destination that router A does not, you just simply forward the packet to the default route, meaning to the ISP route, because that's the IP address that we used. Of course, if you don't know the IP address of your service provider, you can always configure default route using the outbound interface, and it will look something like this, right? IP route 0000 0000 and then the outbound interface. To verify static routes, or default routes for that matter, you can always use the show IP route command, and this command will display the routing table or the routing database of your router, and over there you will see all the static routes and all the other routes that your router actually uses. So let's see an output of the show IP route command. If we type it, you get the following output, right? You have some explanation here, and then you see the paths to all the possible networks or destinations that your router can reach. So C stands for directly connected. That means that the network 12.12.12, for example, is directly connected on serial 0/0/0. That means that this interface 00/0/0 is having an IP address that belongs to the network 12.12.12.0. The same thing is for the 192.168.1.0, which is directly connected on the F800, and that means it has an IP address on that network. The C stands for static routes, meaning that those destinations here that are in the routing table are provided to you by a static route, meaning you typed it manually. So let's see how you can say it. So the destination network 192.168.2.0/24 has an administrative distance of 1. That means that the static route that is providing me a path to this network has an administrative distance of 1 and is reachable via 12.12.12.2. So in other words, if I ever want to reach the network 192.168.2.0, I have to send my packets throughout 12.12.12.2. The second static route, we didn't specify the next hop IP address, so for that reason it actually shows the directly connected on 000. So it says that if I ever want to reach the 192.168.3.0 network, I have to send my packets throughout an interface 0/0/0. And remember, the static routes, when you don't specify the next hop IP address, but you specify the outbound interface, it will have an administrative distance of 0 and it will appear as directly connected, even though it's actually not directly connected. And you know that because you have an S that stands for static route instead of C that stands for directly connected. So that's it. Very basic, very easy, very simple static routes. All you have to do is figure out where your destination is, next hop IP address, and or outbound interface. But just to review what we just did today was that we talked about the different routing operations, meaning how actually routers find out paths to destination networks, and we figured out there are two ways, either static routes or dynamic routing protocols. Then we configure some static routes, and remember, of course, again, you have two options to configure static routes, either with next hop IP address or an outbound interface. Then we talked about the default routes, because any route in the world cannot possibly know all the paths to all the possible networks. in order to keep them in the routing table. But yet again, they need still to have a path to that network in order to reach them, and the default route is the best substitute for that. Also, in the end, we figured out that we can simply use the show IP route command to display the routing table of the router, and there we'll see, what static routes our router use. Thanks for studying CCNA with Vambar, and have a great day.